So in this video, I will be discussing code forces around 933 read for division 4. So I will be discussing problem number D and E in this set. So I will not be discussing first three problems as like they are pretty much easy. So I will be discussing D and E part. So yeah, let's start with problem number D, harder problem. So I will discuss it from here. So for example, let us take a array. Okay. Uh, so yeah, we are given this particular so we will be given an array like this, okay, and we have to construct another array from this particular array. And how we can construct this, for example, mm, like the mod, we can say the value of the mod of an prefix array, the mod of an subarray. Okay, so the mod of an subarray is the number of the maximum occurring element in that. Okay, for example, the if I construct an array b over here, for example 4, what is the mode of the array b till first index? That is 4, because 4 is the most occurring element, right? Now again I'll get the 5. Okay, now I'll write 5. Okay, what is now the most occurring? Now my 4 and 5 are both occurring one times. Okay, then the most occurring is like 5 only, because they are both most occurring, so I'll consider 5. Okay, done. So in this particular manner, I have to construct array b such that the mode at ith point is the a of I, and this is the array a. Okay, done. Let me repeat. I have to construct another array B from A such that the mod of A of I, the mod of the mod till B of I is equal to, or I'll repeat, the mod till ith index should be equal to A of I. Okay. For example, if I write it another 5 over here. Okay, then what is the mod till this index? That is 5, because 5 is the most occurring element. Right. So in this manner, I have to construct another array B such that the mod till ith index is equal to A of I. So how I can construct this particular array? Okay, I'll tell you how. It is pretty much easy, it is easy problem, but let me tell you why. So there's a catch in this problem. For example, for each and every element which is occurring in this particular array, that will be always be smaller than n. Okay, this is given to us that n is at max 10 to the power 5, and my each number in my element should be always be smaller than n, right? Which means my a of I should be always be smaller than or equal to n. Okay, done. So what does this hint? So this is a very big hint in this particular problem. But what is that hint? So that hint is simply that for each and every element which is occurring in this array A, I'll use that particular number only once in my array B. What does this mean? I'll tell you what does it means. For example, it is 4 is here, so I'll write 4 because first element will always be occur, right? Because that is a mod of this mod till first index, right? So first element will always come. Now 5. I'll write 5 because 5's frequency is 0 and 5 hasn't been repeated yet. So I'll write 5 here. Now 5 is again here. So should I write 5 or not? Just tell me. So I will not write 5 here because this it is given to us. For example, if 4 and 5 are both maximum occurring element, then the mode till ith next will be both of the numbers. Okay, which means it does not matter whether 4 is occurring or not. My 5 is occurring, so yeah, I'm good with that. So now I am in this index. So what should I write? I'll not repeat any number. That is my rule over here. Okay, I'll do not repeat any number. So I will use that number which is not been occurred in the array. And okay, what is the element which not been occurred in the array? That is okay. I'll tell you. I'll also maintain a new number that is new. Okay. For example, x. X is a number which is not been repeated in my array A. How? So at what value x will be started? That is 1. Okay, done. I'll check whether I can put x over here. Yes, I can put because x is not been repeated yet. So I'll put x. Now I'll increase x by 2 because x is being used. Okay, done. I'll increase it to 2. Okay, done. Now 5 is again here. I have used 5 over here. Yes, so I will not use 5 again. I'll try to use another number. But what is that number? I'll use x. Tell me x, what is the next number which I can use? He'll tell that is 2 is the next number which is not been used in the array. Okay, then write 2 over here. Now, how is it like beneficial to me? I'll tell you, because each and every number is smaller than n, right? So I can so this loop can be at max that the finding the next number which is not occurred can be at max run till 1e5 only, right? Because my any number can't be greater than n, right? And n can't be greater than 1e5. Okay, done. But now, how it is beneficial to me to writing each and every number only once? Now you can see. my if each and every number is only been written once, then that number will be mod. In this case, you can see if I write any number over here except the 4, 5 and 2, then my mod will be 1, right? So I will not write 1 all, then I will not write 4, 5 and 2 over here. I'll write another number. But what is that number? I'll ask x. I'll increase x. What is the next number? That is 3. Okay, I'll write 3 over here. Done. Now I'll again come to next index. What is the mod? Mod is 1 again, because what? Because 1 is one among the highest frequency number. Okay, but what number to come here? Now I'll increase it to 4, but 4 is already been occurred, right? So I'll not write, I'll increase this x until my frequencies of that number is 0. But you can see frequency of 4 is 1, 5 is 1. So I'll increase it to 4, I'll increase it to 5, then 6. 6 is never been occurred before, right? So I will write 6 over here. Now next, what number to write at this 2? This is 6. So what number to write at index, at this particular index? Now you can see that my 2 is already been occurred. So I'll not be not writing 2. Now what is the next number which I can write? That is 7. Okay, done. I'll write 7, and similarly 8. Okay, done. So this is the answer array. Hopes you get the point. So what is the catch? I'll only write one integer only once. Okay, done. But how to fill the filler element? For example, here in this case you can see my 5 has been already occurred. Then what number to write? I'll use a counter x and increase it and find the next number whose frequency is 0. I'll write it because each number will always become 1. Will always be occurring once in my array. Okay, done. So this is the only solution and explanation of this problem number, whatever it is, D, I think so. So I'll show you the code also. So the code implementation I found in the comment section. So yeah, don't blame me. Blame me if it is someone's solution. So yeah, I've picked it up from the announcement section. So yeah, right. So I'll take it and just because of implementation. Yeah, this is the array A. I'll take the input and write. I'll increase the frequency of each and every element. Right. I'll maintain a map for the frequency, and my maximum number can be 1 5 only and can't be greater than n. So yeah, I'll make it till n plus 2. Okay, done. I'll make another array B, that will be my answer. Answer array. This is the x which I'm talking about. Okay, this is the x which I'm talking about. I'll make x and increase it until I found another number whose frequency is 0. Okay, done. Now I'll also maintain a maximum frequency because that is needed, right? So I'll iterate in my answer. So this is the needed. So this is the number which I currently want, whose frequency I want to be maximum, because this is a of I. If index is 0, which means I'll always put the that index only, because yeah, that there is no need of computation. So just assign b of I is equal to needed, that is a of I, and increase its frequency and update the maximum frequency to 1. But if it not, but if it is not index 0, then what I will do? I will check if frequency of needed, which means the frequency which is needed at this point, is smaller than the maximum frequency, then I know that this particular index has not been occurred yet in my particular array. So I'll assign it to that particular needed array, as increase the frequency of that needed and assign it to maximum. Okay, done. Now next, if my frequency is greater than the maximum frequency, then what should I do? If it is greater than, then I'll check if the maximum frequency is 0, which means the frequency which I needed is 0. Like I think so this can't be possible, but yeah, you have to consider it also. Like I'll assign b of I is equal to needed and increase the frequency and update the maximum frequency. But yeah, here comes the next part. If my frequency is also satisfied and my maximum frequency is also not 0, then how to fill the filler part, which means I'll increase my x. Here you can see I'll increase my x until it is smaller than n, and its frequency is not equal to 0, which means I'll find that number whose frequency is 0. Here you can see I'll add, then I have find 8, 7, and after 8. Why I'm choosing 8? Because frequency of 8 is 0, and I'll always put only one number, occurrence of only one number. Every element will always occur once in my answer array, right? So I'll just run a loop and find the number whose frequency is 0, and it is not equal to needed also, because I want another number. Here you can see, because this case will arise here, has arise here, because after 3 I have come across the 4, because but 4 has already been occurred. So I'll also make a check because that is not needed to me, right? So like after finding the new number, I'll check if it is smaller than n and its frequency is also smaller than maximum frequency. Yeah, this check is not needed here, but yeah, I think so the person who's written it must be thinking of something else. So yeah, but yeah, I'll just assign it to a new number and update the frequency. And here's, and if it is not the frequency case, then just assign the needed number, increase the frequency and update the maximum frequency, right? And print the answer in the end. So if I show you the documentation also, like I have read it also, they're also saying the same thing, right? Observe that if you have an array A where all the elements are unique, which means every element is occurring only once, that they will always have frequency 1. Therefore we can have, therefore they can be classified as the mod, right? Because they can be mod till the itx, right? This is the thing which I was talking about. Therefore it follows strategy for the construction is to just construct an array where each prefix, where for each prefix the last element of this prefix appears in this array at least once, which means at least once condition should be satisfied. And yeah, and we can do it. And for example, for each a of I, if the value has appeared previously in the array, you can use a set to check this. Or like they are using a word set, but you can also choose a number like this and increase it until you find the frequency 0, right? So yeah, and you can set it to like, and set the b of I equal to some random number that isn't used elsewhere in the list of a of I. This is the thing which they are talking about also. But yeah, and keep going until you find the answer. Yeah, so that's the solution of problem number D. Hope you get it. Please free to ask me in the comment section if you don't get it, or just text me on the LinkedIn. So this is a problem number E, that is insane problem. So we are given some numbers k, l1, r1, l2 and r2, and the person wants to find the number of ordered pair x and y such that x is smaller than, x is in between l1 and r2, l1 and r1, and y is between the L2 and R2, and there also exists a condition such that y divided by x should be equal to k of n, which means it should be equal to some power of k, and k is also given to you. Find the number of integers which are possible. So I think so this is pretty much simple problem, but why? Like I'll tell you why. You have to just modify the condition. That's it. And like I'll tell you one more catch. Like for example, this is given to you, right? L1, R1, L2, R2. There, like you will always know that your, if you're, like this is the condition that y is divided by, and it should be a form of k of n, right? And you know one thing, that maximum value of k of n is 1, right? That my k of n will always be greater than or equal to 1. Okay, done. Which means if it is equal to 1, then I am sure that my y will always be greater than or equal to x. It can't be. My x can't be smaller than y, right? Because then it will be smaller than 1, and it can't be possible. So what does it signify? It simply signifies the conditions. What are the conditions? That my L1 is smaller than R1, is smaller than L2, okay, L2, and is smaller than R2. So this is the unset condition in this problem. So yeah, this is also a condition that L1 R L1 R1 L2 and R2. This is the condition which will also be there in the problem. So yeah, this makes it easy for the problem to solve. So yeah, okay, next part. The statement given to me was this, like x divided by y divided by x should be equal to k of n, right? K of n. If I reverse the condition, which means if I put it in this way, y divided by k of n should be equal to x, right? And what are the maximum and minimum value of y? The maximum and minimum value of y is simply L2 and R2. Yeah, so my y will always be in between the L2 and R2, right? So how can find? Just construct an array previously of all the powers of k, right? But you know also one thing, that k of n, you will be considering whether it is smaller than R2 or not, right? Because your y is smaller than R2, then your k of n should always be smaller than R2 also, right? So hope so this condition is also got also in your minds. So yeah, now how to find the number of x, right? Because that is a thing which is given to me, like, which is asked to me, like the number of pair of x and y which satisfy this condition. So I can simply check it by using the lower bound and upper bound. This is not basically the binary search terms which I'm using, but the simply the lower value and upper value, right? So yeah, if you know one thing, like that I have tell you before, that your k of n should be smaller than r, r of 2, because y is smaller than r2 and k of n can't be greater than y. Okay, done. This is the one condition. Now next, I'll store all of the powers of k of n in my array. Okay, in an array. Done. I'll store it. Then what next? After storing it, I'll check from the conditions only whether, like, the maximum x which can be there, which is satisfying this condition, and the minimum x which is there, which is satisfying the condition. But and that will be like uh that number. Okay, I think so I'm bit confusing you. So this is the power array of all the k, right? I'll take one number from here, one power of k over here. Okay, done. How I'll compute it? Okay, my minimum number can be L1, right? So L1 must be the power which I'm getting. Okay, the power which I'm getting divided by the power and minus 1, because this is the seal function. This is the seal function. Okay, I'll just write it then this only, divided by power of seal. Okay, done. So this is the maximum value of x which I can get. Tell me yes or not. Yes, because this is the only condition given to me, because I'm taking the k of n as a power. I'll iterate on each and every of this power and find the number of counts. And what is the minimum value? Okay, this is the minimum value. And what is the maximum value? Maximum value will be r2 divided by power and the floor of this particular function. Just divide these two particular numbers for each and every power, and you'll get your answer. So yeah, I think so you get the explanation, right? So I'll repeat it once again. My k2 will be always smaller than r2. I'll find all the powers, right? After, next what I'll do, I'll find the minimum x which is satisfying the condition, and that will be L1, because L1 is the smallest number which x can be, divided with the power which I get it. And what is the maximum number which x can be? That is r2, and divided by p. So yeah, just check the condition and subtract these two both. Like for example, this is your min and this is your max. For finding the answer, just subtract max minus min. So yeah, this is the answer for each and every power. Just repeat it for each and every power in this particular array, and you'll get your answer. I'll show you the code. Just find the power of each and every number, and until my power is more than r2, right? Because you know this thing, that my power can't be greater than r2. Okay, then just find the minimum of x. That will be the maximum of L2, because it should be greater than L2, right? It can't be smaller than L2. Okay, then L2 uh, plus power divided minus 1 divided by power. Okay, because I want the seal function, my this number can't be smaller than L1, right? So I'll taking the seal. Find the maximum number. That will be r2 divided by power. That will be r2 divided by power. Okay, done. Because now I'll take the floor, because this can't be greater than r2. Just subtract. Okay, just check this condition, and because it can't be, my maximum number can't be smaller than my minimum number, right? And increase the count. Maximum minus minimum plus 1. Okay, I think so you know why I'm adding plus 1. So yeah, so hope so you got the problem. And you may notice this condition also, because you know one thing, that it should be greater than L1. It can't be smaller than L1, and uh, it can't be greater than R1. So I'll taking as the minimum of this. So yeah, hope so you get the problem statement and solution also. If you have any notes, please do like comment me. Please do put it in the comments and ask me on the LinkedIn if you want. And yeah, I'll surely reply. Please do ask the doubts if you have any. So yeah, that is for the today's video. And yeah, bye.